This part is ready to go into SolidCAM for programming. We need to create a new CAM part using the SolidCAM drop-down menu. SolidCAM, New, Milling. We can click OK to accept the file name and location for the SolidCAM part. We will need to define the coordinate system, also known as the part 0, for this job. There already is a coordinate system created using SolidWorks. To use that, we will click Select Coordinate System, then select the already created coordinate system from the list. Then click Accept. Now we can click OK to accept the default Z levels. Now to define the stock material for the job. We will define this stock material by a 3D model, since there already is a solid body created representing the stock material. We will click on the stock body, then accept the selection. Defining the target is similar. We will click Define 3D Model, then we can select the target geometry. Now click OK to accept. Now we can click the green check mark to complete the CAM part definition. To make a new 2D iMachining, we can click the 2D iMachining icon on the SolidCAM operation ribbon. Since this is our first iMachining operation on this part, we will need to define the databases. By clicking Next, we will be taken through the process. We will now need to define a new machine database. By clicking the green plus icon, a dialog will prompt us to enter the name for the machine database. Clicking Save verifies the database has been created. There are 3 important values needed in the machine database. They are represented by the red fields. We will need to enter the maximum RPM of the spindle, the maximum feed rate G1, and the maximum power of the spindle. Clicking Next will bring us to selecting a material database. These are provided. All we need to do is select the desired material. If there is no database matching the material we are cutting, selecting a similar material will be fine. Clicking Finish will bring up the 2D iMachining Operation Manager. For this example, we will select a simple closed pocket. We will click Define and then select one of the edges of the closed pocket. Clicking Auto Constant Z will close the geometry. Now we can click Accept and bring back up the Operation Manager. Moving down the tree, next we need to create a tool. Clicking Select will bring up the tool table. This will be a flat end mill with a 1/2 inch or 12 millimeter diameter with 4 flutes. Clicking Select will close the tool table and bring back up the Operation Manager. Next on the tree is levels. We can pick the upper level of the pocket, and then we can pick the pocket depth. Now we can save and calculate. After the calculation, we can view the toolpath using the simulation button at the bottom of the dialog. First, we can play the toolpath in HostCAD. This shows the wireframe toolpath on the model. Now we can use Solid Verify to view the tool moving through the solid stock material.